All right, we are dealing with cubic functions. We want to find out the maximum and the minimum values of a cubic function. The way you know that if a function is cubic is the first x, or the first variable, is to the power 3. Right? If it's to the power 3, then you know it's a cubic function. If the first variable was to the power 2, it would have been a quadratic function. If the first power is to the power 1, it's a linear function. So this is the general shape of a cubic function, like this, right? And with this question, we want to find the minimum and the maximum value. Basically, these are the points of the cubic function where the gradient equals 0. Okay, so these two dots I've put here, the gradient here is 0. So for this point, that's the maximum value. And for this point here, that is the minimum value. So those are the values we want to find. All right. So the first thing, which is step 1, is you need to derive the cubic function. Right, so here we're going to use calculus to derive our cubic function. We're going to be using the power rule. Right, so with the power rule, this is how you do it. Right, first you multiply the exponent. All right, we're going to derive each of these terms in this equation here. Okay, so we start with x cubed. First, you multiply the exponent of the power, this 3, you multiply it by the coefficient. 3 times 1, that is 3. Then after you multiply the exponent with the coefficient, you always subtract a 1 from the exponent. So 3 minus 1, that is 2. So our first term in this equation is 3x to the power 2, 3x squared. All right, we derive our next term. Okay, the same thing. Multiply the exponent, 2, multiplied with the coefficient. 2 times 9, that is 18. All right, then you subtract a 1 from the exponent. All right, so 2 minus 1, that is 1. Plus, we come to the next term, 15x. So this is like 15x to the power 1. So you multiply the exponent with the coefficient. 1 times 15, that is 15. We subtract a 1. 1 minus 1, that's x. So we have 15x to the power 0. Now if you remember from indices, anything to the power 0 is 1. Okay, so this x to the power 0 is just the same as 1. 1 times 15, that is 15. So we just remain with 15 here. Then for numbers that don't have a variable attached to them, they disappear. Okay, they just go. You don't need to show how they go. All you need to do is just remove it from the function. Yes. Any questions? So that is that with step 1. Step 2, you need to equate the first derivative. So this 3x squared minus 18x plus 15, this is the first derivative. And what you're going to notice is the first derivative is a quadratic function because it's to the power 2 here. So step 2, we need to equate the first derivative to 0 so that we can get our critical points. So remember, our critical points, these are the points on the cubic function where the gradient is 0. So here where I said the maximum value here and the minimum value there, those 2 points are our critical point. So when you hear the word critical point, it's just a point on the cubic function where the gradient is 0. And this is where you find your maximum or your minimum. So basically, we have to solve this quadratic equation. So we equate this quadratic equation to 0. All right, so there are two ways we can do this. First off, we can see that all the terms in this function are all divisible by 3. All right, so you can factor out 3 where you simplify this quadratic equation. Okay, if you divide 3x squared divided by 3, you remain with x squared minus 18x divided by 3, you remain with 9x. Or 6x, not 9x. Fifteen divided by 3, that is 5. So here we've simplified our quadratic equation. All right. We've just factored out 3. Okay. So that we can simplify the quadratic equation, and we can solve this quadratic equation by factorization. If you remember, first thing you need to do, list your A, B, and your C. A is just the coefficient of x squared, the number in front of x squared. All right. So the number in front of x squared is 1. B is the number in front of x. In this case, it's negative 6. C is the number without the variable. All right, so in this case, our C is 5. So remember, with quadratic equations, you multiply A times C. All right. Once you've done a lot of quadratic equations and you're comfortable with them, you don't really need to do what I'm doing here. The reason why I'm doing this is for in case those who have forgotten how to solve quadratic equations, this is how you do it. All right. But once you've done many of them, you won't even need to do this. So A times C, basically 1 times 5, that is 5. So we have to find 2 factors of 5 such that when you multiply these 2 factors, it should give you positive 5. And when you add these 2 factors, it should give you negative 6. Okay? You have to find 2 factors of 5. When you multiply them, they should give you this 5 here, the product of A times C. All right? And if you add the 2 factors, they should give you B. So those 2 factors of 5, it's 1 and 5. And we make them negative. Okay. If you multiply negative 1 times negative 5, it will give you this 5 here. If you add -1 plus -5, it will give you -6. All right. So our factors are -1 and -5. So you just write here x minus 1 x minus 5. Okay, and then you equate them to 0. Right, so you solve both of them. X minus 1 equals 0. X minus 5 equals 0. So when you take x, I mean, if you take -1 over the other side, it becomes +1. And if you take this -5 over the equal sign, it becomes +5. So our critical point, okay, is x equals 1 and x equals 5. Let me just write that properly here. So the critical points where the gradient of the graph equals 0 is where x equals 1 and where x equals 5. Yes. Are we okay with this? Any questions? Mm-hmm. Uh-huh. No, it's actually good that you brought up that point. Because usually these type of questions, the way it is, you see in most books they've solved it like this. But let's do it the step-by-step process. All right. After you find the factors here. So thank you, sir, for bringing that up. So what happens here, colleagues, is after you found the two factors of 5, okay, that -1 and -5, you are going to split this b here, this -6. All right. So what's going to happen is it's going to become x squared. Now this is where you have to be careful so that you put you group them properly so that you can factorize. All right. So x squared minus 1x. Okay, I'll put the 1x because this one has also got a 1, so they'll be easy to factorize together. Minus 5x. All right, plus 5. All right, colleagues, have you seen what has happened here? This -6x has become -1x minus 5x. All right, because remember the factors we found are -1 and -5. Then you can factorize by grouping. All right, so let's look at x squared minus 1x. So what is the common factor here? The common factor is x. So you're going to say x squared divided by x, that is x, minus, we can say negative 1x divided by x gives you negative 1. Okay. Then we go to the second portion here. Negative 5x plus 5. We factor out negative 5. So you're going to say negative 5x divided by negative 5, that is x. Then you're going to say 5 divided by negative 5, that gives you negative 1. So we've seen these two are common, x minus 1, x minus 1. So what you're supposed to write is like this. You're going to say x minus 1, x minus 5. So that's how we came to this here. So sir, thanks for bringing that up. Yes, any questions? Right. So I also show you how to solve it when the leading coefficient is greater than 1. Let me just finish this question here, then I'll show you how, if you don't want to simplify it to this. Okay, if you want to just stick with this, actually maybe we can even do it here. Okay, 3x squared minus 18x plus 15. So you go through the same procedure. All right. 3a equals 3, b equals negative 18, c equals 15. So you're going to start again. You're going to say a times c, which is going to be 3 times 15, gives you 45. So now you have to find two factors of 45, that when you multiply those two factors, you get 45. When you add those two factors, you get negative 18. So those two factors are 15 and 3. If we make these both negative, negative 15 and negative 3. Negative 15 times negative 3, positive 45. Negative 15 plus negative 3 gives you negative 18. So now once you've got those two factors, you have to split this 18x. So it becomes 3x squared. So when you're grouping, advice is put common numbers together, okay? So you're going to put this negative 3, and these factors, put an x, attach an x to them. So you have, so this negative 3x came from this 3 here, minus 15x plus 15. So same thing again, you split it in half, all right? So you will factorize. Here, what's the common factor? The common factor is 3x. So we're going to say 3x. Right, so it's a 3x squared divided by 3x. You get x minus 3x divided by 3x. That is 1. Then on this other part, find what's the common factor here. It's 15, so it's a negative 15. Put negative 15 here. So negative 15x divided by negative 15. That gives you x. Positive 15 divided by negative 15. That is negative 1. So we have an x minus 1 here. So since in our brackets we have x minus 1, which is common, so I'm going to say 3x minus 15, close brackets, x minus 1. Then you equate to 0. Okay, so 3x minus 15 equals 0. You take 15 over the equal sign. Okay, if this 15 goes over the equal sign, becomes positive 15. All right, then we divide both sides by 3. So again, we have x equals 5 and x equals 1 as our critical points. Mm-hmm. I don't really have a straight answer, but because there'll be times where you can't simplify and you might see big numbers, so you might not be able to simplify. So what I would advise is be also comfortable in the big numbers, because not always you have the you have the luxury of simplifying. Okay. So the next part now, we've got our critical points. So we have to go into step 3 where we do the second derivative test. All right. So the second derivative test, what's going to happen is we're going to derive our first derivative. This 3x squared minus 18x plus 15, that's the one we're going to derive. Okay. Once we derive those values, once we derive that equation, we're going to substitute x equals 1 into that new equation and x equals 5 into that new equation. So this is where you must remember this law, right? After you plug in your critical point values, right? If your answer is less than 0, you have a maximum. Okay. I know it would be tempting since you're saying less than 0, so it looks as a minimum, but no. Then if you plug in those values and the value that you get is greater than 0, then you have a minimum. So let me illustrate what I'm talking about. I can erase this, right? Okay, so first things first, we need to get our second derivatives. Okay, so in some books, you see second derivative represented like this. Other books, you're going to see it as d x squared d squared y, all right? This, whenever you just see this, it just means I've derived the function the second time. Okay. These symbols should not even confuse you. It's just telling you have derived the function the second time. So here we're going to derive. So if in case you simplified to bring it here, you can also derive this function. Okay. Or you can derive this unsimplified function. You'll still get the same answers. So let's use the complicated one. Okay, so we have to derive 3x squared minus 18x plus 15. So in second year, you won't find any of these deriving things, all right? But in third year, you'll find these, they'll come again. So please do not forget, because they'll come back in full force. So this is the power of differentiation. Okay, so you multiply the exponent. So we start with this 3x squared here. We derive it. Okay, our exponent is 2. So you say 2 times 3, you're going to get 6. Then you always subtract a 1 from the exponent. Always. 2 minus 1, that is 1. So remain with x to the power 1. Excuse me. Minus, we come to 18x here. Okay. So it's like 18x to the power 1. So you're going to say 1 times negative 18, you get negative 18. And you subtract a 1 from this exponent of 1. 1 minus 1, that is 0. So remain with 18x to the power 0. Now, so as I said in the exam, you don't need to show this 18x to the power 0. Okay. Just leave it like this, 18. And also the constant, the number without a variable, it just disappears. You don't need to show how it disappears. Okay. It just goes. Yes. So those critical points, that x equals 1 and x equals 5, these two, we're going to substitute them into this new equation. And our values, whatever value we get, we're going to compare it to 0. If it's less than 0, maximum. So if it's greater than 0, minimum. So we start with x equals 1. If you substitute x equals 1 into our second derivative, which is 6, x minus 18, you're going to say you substitute x with 1, so 6 times 1 minus 18. Okay. 6 times 1, that is 6. 6 minus 18, that is negative 12. So negative 12 is less than 0. So what you're going to say, x equals 1 is your maximum. And when you graph this equation, at the point where x equals 1, it will have the highest point. Then We substitute now x equals 5 into this equation here. So we're going to say 6, open brackets, 6 times 5, minus 18. 6 times 5, that is 30. 30 minus 18, that is positive 12. So positive 12 is greater than 0. So x equals 5 is our minimum. Okay. Mm-hmm. Okay. Yes, less than 0, that's maximum. Then